Hello, everyone. Welcome to the latest and greatest .NET Runtime and Managed Languages Stand-Up. I'm one of your hosts today, Bill Wagner. I am responsible for the C# content on learn.microsoft.com. And with me is Mads Torgersen, the lead designer for the C# language. We're here to talk about C#, both what's coming out with C# 13 and probably some things in the future. So I will turn it over to Mads immediately. Also, I should say that behind the scenes, we have Chet Husk, who's also one of our hosts, monitoring chat and helping us keep everyone, everything, the right things on screen and so on. So with that, Mads, I'll let you introduce and then we'll get going.
Yeah, hey, so Bill said the pertinent things about me. We have, as I'm sure is no surprise to anyone, we have a new version of .NET and C# coming up next month. There's a nice little online conference, .NET Conf, where we will release and celebrate the new version of all of that. And so we do this every year now, and every year there's both a new version of .NET. We're getting to .NET 9 now, so the counter is going faster than it used to in the old days. And C# will be up to C# 13. And we've been working on a lot of big and small things during this last release cycle. Some of the big things are so big that they won't be in C# 13. They're kind of headed for C# 14 or later. We try to always do a blend of small and nice features and land some big ones and also start some big ones so that C# keeps getting like substantial evolution, even though we have this every year kind of release cycle. So what we can do today, Bill, is, and I know you're in the C# design team too, is, we can pull up Visual Studio and have a poke at some of the things that are coming out in C# 13. And if we want, we can talk more informally about some of the things that that we are actively working on together.
I think so. I think that's definitely the way to go. I think a good overview of what we're doing with 13, including one of the preview features that's coming out just now that we want to get some feedback on, and then let's look forward at some of the big things that we're working with. So you want me to add the screen already, and then we can start looking at code, or just start walking through things? All right,
it's your show. I will, but yes, go for it.
Well, you're the guest. We always work with our guests. So what should I be excited about in C# 13?
Well, I think, as we're learning how to ship every year, one of the things that happens more and more is that we have these story arcs that go through multiple releases. We started a big story arc in C# 12, which was about collection expressions. And so you see here the an example of a collection expression, right? That's an expression that goes to pretty much any collection type. It has some elements in it, and the collection will be initialized in the appropriate way for that kind of collection. In this case, it's an array. And so we realized, now that we've figured out how to initialize in a uniform way all these different collection types from elements, well, now's the time to apply that back to one of C#'s oldest features, which is params. So we have params of T here, which has always meant that you were able to just pass some elements, and an array will automatically newt up and pass to the body of the method. But if we kind of take that and combine it with the collection expressions machinery, if we kind of rethink params as really just putting square brackets around those elements, then, for instance, we could do INumerable of T here, which is one of the longest requested features for C# is, why can't I have params with IEnumable in particular? Oftentimes you see in APIs, people have an IEnumable overload so they can take any collection that implements IEnumable, and then they have an array overload just so they can have params. But why not just join those two together?
I've definitely been asking for this one for years. But one other thing on this one. What's that?
I know you have.
And see, now one of the things though now, since we've done all this work with ref safety and span and read-only span, the way you've written it right now, it's definitely going to do some allocations, right? Because it's going to have to create some collection that implements IEnumerable, and that's probably one allocation. And I know with collection expressions, we did a lot of work. So, the compiler knows there's two things, so it's only going to allocate a collection big enough for two things, but I'm still allocating. So
that's exactly
we fix that?
Yes. So one of the things, and again, this is also something that collection expressions themselves can do, that we're kind of just building on for params collections, is that you can take one of the span types, span of T or read-only span of T, which are these ref struct types that represent collections that can be on the stack, for instance. They don't have to be allocated. They really just represent viewing some contiguous memory with elements of a given type. And so we can also do params read-only span. And now the compiler is free to, and very often will, allocate something directly on the stack, just where you're at right now in your call stack, and give you a read-only span to that. And when you think about it, that's kind of equivalent to passing multiple parameters yourself, right? They also get passed one by one on the stack. So it really is the same allocation profile as if this had been a method of n individual T's, if you will. So that is kind of cool.
And one of the things I always like with these things is it makes the obvious, most readable thing I could write the thing that's going to perform really well, right? Arrays have to allocate, and I have to do that. And now, I don't have to change my API as much. I don't have to do all kinds of, oh no, make sure you don't use params, make sure you create the collection and call it that way and do this, so I really like, that we're doing these things that maybe look small, but it's just going to make your code faster, because you can, the compiler's doing more performance engineering for you in a way.
Yeah. And one thing I really like is that with the same new little feature here, we are both accommodating like the generality of IEnumerable of T. We're also accommodating the performance scenario with the read-only span of T, really under the same scenario. And if you want to talk about one more scenario, maybe this, if you think about immutability, we have a whole set of immutable collections as well. If that's your game, now you can also have, an immutable array overload that is also params, because those we also know how to create from whole cloth, right? So it kind of covers all the bases there, and you're not like artificially backed into specific preferred types such as array. Now, I don't know if you want to talk more about this feature, because there's a big red squiggle here that is sort of like an invitation to segue into another one if you want.
Oh yes, let's definitely segue.
Okay, but I think params. It's one of those little. It's a feature that doesn't really add concept count to C#, and I really like when a feature is super useful and it doesn't really make the language more complicated. On the contrary, we remove a restriction. Whenever we can do that, the restriction that it has to be arrays, right? Whenever we can do something like that, I really feel good about that. Now, I added too many overloads here in the sense that my call can no longer figure out which one to pick. Before, when we had only read-only span and IEnumerable, we made it so that read-only span and span are better for overload resolution than arrays and any interfaces that arrays implement, like IEnumable, for instance. So we kind of do. So I just want to mention this briefly. We started down a path of taking the spans and making them more first-class types in C#. We actually call it first-class spans. They've been a library type, and there've been some user-defined conversions and stuff. But we really do everyone a favor if we start treating them specially in C#. And we started down that path in C#13. And one of those things is that overload resolution knows how to prefer them better, if you will. Like as in this scenario here, there will be more kind of first-class span features in C#14 as well. So that's like a theme that we're not quite done with. But so while both of these, the second and the third method, are better than the IEnumable one, they're not better than each other. There's no relationship between those two types, and so we need to disambiguate somehow. And the library I built here isn't really, that's probably not something I would write from scratch, but I might have already had my IEnumable and my immutable array overload, and then I added the read-only span overload because I wanted to improve performance, and now I have ambiguities in existing user code. And especially for evolving libraries like that, it would be really cool if I could tell, one overload is better than the other. And that's what the overload resolution priority attribute is for. So this is a new little attribute that takes a number, and it tells you how important is this overload. And if it's a positive number, then it's more important than the default, which is 0. So I'm kind of saying prefer this overload. And what you see here, if we hover, is that indeed I get the immutable array overload. I can also say, well, I kind of don't want this to be preferred anymore. Maybe it's mostly there for binary compat or stuff like that. So I can give it a negative number, and then everything else is better than it. You can see you get right. The read-only span one. So this is a little tool for library authors to better evolve their libraries while, helping the consumers of the library get the overloads that are right for them now for the present time, but without the hard deprecation hammer that has its own kind of breaking issues.
And what I like about this is it now means library authors can add these new, more performant APIs, and just by adding an attribute, you don't have to worry about, did I just make a breaking change? Did I just do something and now, 1 million users are going to tell me my code doesn't compile anymore because you changed this on me.
Yeah.
And I can just say, no, it's going to pick this one and you're fine.
Yeah, it kind of gives you a new option in the game, right? Where a lot of these, as you said before, these like optimizations that happen automatically, maybe just when you recompile in a new version of C# and .NET, they kind of function by, technically they're breaking changes in that they make your code do something different. They make it pick a different overload or something like that. But because we are doing it in a curated fashion, that's fine. The behavior will be the same. The performance will be better. Like we can control that because we're the library authors too, right? But what can sometimes happen is you need to leave the old overloads already there, and then you get new ambiguity errors and so on if you're not careful. And this helps with that kind of thing. So we're really happy with this one, and we're already using it in many places in our own core libraries in this release as well to roll out new overloads that are beneficial in various ways.
So I'm sensing from chat, I'm seeing a lot of people asking for, big things and so on. There's one other one I definitely want to talk about a little bit in 13, because it also helps illustrate a bigger story that you've alluded to here, is the new features around lock.
Sure. Yes. And I kind of anticipated you would bring that up. So one of the things that in hindsight you might call a mistake in C# is that we have always had the lock keyword, right? And why is it a mistake? Well, because the lock keyword is really nice syntax for what we thought in the very first version of C# was best practices around locking, around managing concurrency. But of course, that is an evolving field. We get, and we have had many iterations of better coordination abstractions over the past more than 2 decades. And so it's kind of a shame that one of them is what you get if you just take the easy language supported route, and that the one you get is sort of the oldest and least optimal one, the one we've been trying to improve on ever since. So what I'm doing here, just to remind people, I have an object that is there solely because I'm using it to lock on. Like every object has a monitor associated with it, and when you use the lock keyword, you are interacting with that. But that's not the best in locking nowadays. In fact, we have a type now in .NET 9 that's called lock. That is, I think we are ready to say, the be all and end all of locking. And it would be, and you create a lock and then you interact with it, and it has a better API, more efficient and more safe and so on. But if we didn't do anything in the language, and I just said, oh, let me make a lock object, and then still use the lock keyword, then it wouldn't use the lock as a lock. It would just use the old objects kind of monitor thing on it. So we made it so that the lock keyword now especially preferences this type. It does the new thing when it sees this lock type. So so you no longer have to have inferior looking code, and you kind of don't fall into the old behavior by mistake.
And the other thing I really liked about this is, when I was doing one of the programs I have that does require some synchronization, I had that old code of, sync object equals new object or whatever. And all I had to do was change that declaration, and now suddenly I get the better behavior. So my upgrade path was 10 seconds, and then rebuild and run all my tests and so on. And it was just, I also really like this idea that now, we can look at the language, and the same thing with params and how the compiler is really thinking about the collection type and so on, where we're taking code that you already wrote, and now it just generates something better and makes your upgrade path easier, you get more of the improvements in the whole ecosystem just by, small changes in your code.
Yeah, it's the thing where it's not, the features aren't really small. They have big impact, and sometimes there's a big implementation story underneath, but they feel small. You're like, oh, that's no big deal. Well, that's great, because we don't actually want you to feel like it's a big deal and you have to change all kinds of things.
And
so,
So I was going to show one question, and then I have the perfect question that just gets us right to the next topic. So when we were talking about overload resolution, does it allow for template specialization? What can I do with generics there?
In overload resolution?
Yeah, for that priority attribute.
Well, I
don't
not sure I understand the question.
Yeah, maybe you can add something. Give us an example of what you would want to write, because I'm not exactly sure what you're looking for there. And then while Pierre writes that one, I want to show this one because it goes right to where somebody's asking about, this. What about this field-backed properties is its official name, the semi-auto properties that's been referred to online.
Yes. Field keyword, sometimes we just call it now, because we couldn't agree on which longer name to use anyway. So let's just call it the field keyword. Well, so that's a feature that is in this release. And let me show it first, and let me tell you why it sounded like there's an asterisk to when I just said that. that it's in this release. Okay, so I have this property here. Let's scroll it up so everyone can see it. And it has an underlying field. Like map is just the underlying field for the map property. But because it does more than just read and write from the underlying field, I couldn't use an auto property for it. Right? It's just not auto properties don't do what I need, because I need to have that locking behavior as well. And so you kind of, whenever you can't quite use an auto property anymore, you kind of fall off the cliff, where now you have to declare a field and risk that other members accidentally use the field instead of the property when they access it, and so on. So you don't have control over it. Well, no longer, because now we have the field keyword in C#, which is essentially, so let me use it here. Look, field is blue when you write it inside of a property accessor. Let's do it here again. Let's replace map with field in these two cases. Well, what that means is if you have a body, a property accessor that has the field keyword in it, that means I am an auto property, even though I have a body. I'm still an auto property in the sense that there's a backing field generated for me, and I can reference it with the keyword field. I don't have to manually write both my accessors if I didn't want the, if I was fine with the default behavior for the getter, for instance, I can still write just get semicolon, the auto property style, but then I can provide a body for one or both, and as long as, even if it's both, as long as the field keyword is in there, we will generate you a backing field, and we will interact with it through the field keyword. So now I can remove this manually written field, and it's sort of I know that any interaction with the backing state is scoped to the property declaration itself. No one else can tinker with it. So I think that is very cool, and we wanted to do that for a while. We took a look a couple of years ago when we started on this, started down this path, at a lot of code in GitHub, and it became evident that there's a lot of code that would benefit from this. That like this pattern is very common, and so I think this is really going to be useful to a lot of people. But let me let you get a word in edgewise first.
Well, I was going to say there's I'm going to start with one question, and then I think I know exactly where you're going. Yeah, let me just find it because it just came by. I lost it. Oh yeah, here it is. It's not in the feature list, and also not in the last RC release. I believe it is in the RC release that came out yesterday. I haven't had the time since yesterday to do it. And you do have to turn on preview features. And I haven't written about it yet. It's on. I will get to it next week, I think, is when I'll write all the docs for field. And that gets me to this one here, which is where I think you were starting with your butt.
Yes. What happens if there's a field named field? Does compilation break? Well, why don't we have a look? The answer to that question first is why this feature is going to ship behind a preview flag, because we decided to do a little bit more of a breaking change in C# than normal, and specifically the let me put this back in. Specifically, the breaking change is that if there's already something called field, we didn't want it to be that that would then somehow override the keyword, because that would be the non-breaking thing to do, but it would also be very confusing, right? I add something called field somewhere far away in a base class somewhere, and all of a sudden my properties change their meaning, right? That's spooky action at a distance. We try to avoid that. So like field really has to be a keyword. It can be very contextual as a keyword. Like it's not a keyword anywhere else. You can see it's not blue up here. And even if you use it in different ways inside of a property accessor is also not a keyword. It's only a keyword when you use it as a simple name, but it is a keyword. And so if you had code like this already, it will now be broken in that sense, right? It'll now mean something else. And we have a whole scheme in place for managing that breaking change, for helping people like fortify against the break before they even upgrade the language version, by giving them warnings ahead of time. Like even before you upgrade it to C# 14, say where this feature will be official, you would get a warning saying, hey, actually, you have this code that will now change its meaning. Would you like to fortify it? And there will be a tooling experience that will give you, that will just like fix all. And the kind of, what I mean by fortify is you can put an add sign, or you can say this dot and or do something, and you can see that turns the field no longer blue. The @ sign always means treat this keyword as an identifier, and of course, when I go and treat it as a member out here, then it's no longer a simple name. And so there'll be ways for you to take those instances of breaking code and fix it, and there'll be a tooling experience for it. There'll be ways to turn it off if you never plan to upgrade to a new language version, and all of that. And Chet was involved in building that infrastructure into the .NET SDK. But because it's a little more of a breaking change and it's a new experience, in the end, we decided we want to give it bake time as a preview feature for a year before we officially turn it loose, so that we are sure that we have the best experience and don't run into something we didn't foresee that is a bigger problem for people than we expected. Right. We think it's the right path for C# going forward to be able to do this kind of breaking change once in a while. But so this is kind of like the canary in the coal mine, and we want to make sure we get the whole thing absolutely right the first time we do it.
Yeah, and two things I want to add here. I think, and again, I am going to get to the docs for this within a week or two, and I definitely encourage people to try it and at least see, what does your code base look like? As Mads mentions, we did searches on, open source repos that we can see, and there's definitely uses of classes out there where fields are named field, and we expect things to some impact here. But it's definitely a useful way to go. And a related thing that is in C# 13, where I really like this feature, is we have partial properties in C# 13. And because the syntax for a partial property looks exactly like an auto-implemented property, you have to declare bodies in one of them to make the implementation real. And now with just this, by using a fieldback property, I can write less code. I just have to do like return at field, and now something happens, and it's enough to say this is the implementation.
Right. Let's get back to the full fieldback property here. And remove the field there. Yeah. So you're mentioning, and maybe we should show the partial properties feature as well. Is that you're attempting a segue into that feature maybe also?
Oh, sort of. I'm not sure how often people are going to use that, but I think it is another bit of the vocabulary that's just been added that I think is just kind of cool.
Yes. Yeah. And if so, to kind of motivate it a little bit, we've had a version of partial methods forever in C#, not forever, but for a very long time, that worked only for private void returning methods. And several releases ago, we kind of upgraded that so that you could have public partial methods. And the way that works is that you have there has to be exactly one definition, like this one here, where it's not abstract, it's partial, but it doesn't have a body. And that kind of says someone else has to provide the body. And the other part down here now provides the body. And the scenario for that was very much generated code, for instance. Like, I'm going to put in the manually written part of my type, that there's going to be a dispose method that maybe I'm going to refer to from other members here. but then it's up to the source generation to provide the implementation of that.
Mm-hmm.
And it's nice to be able to like put the signature of it in the manual written code and maybe guide the source generation even that way. And it was just always a pain that you couldn't do the same for properties. And so now you can. And so we can make this map property partial, and it's going to complain that it must also have a definition part. Okay, well, that sounds just like the method. So let's go up here and put a definition part, which is that, but with a getter and a setter. And now it's actually going to complain down here that they don't match accessibility because it's a private setter. So we get help in fixing that. And now we have partial properties as well. Definition part here and an implementation part down here, which is really nice. And but as you say, the problem properties, and the reason we haven't done it for many years, is that if it didn't say partial here, this would still be allowed, and it would be an auto property. So as opposed to the methods where doing it without partial would be an error, for properties, it means something else. And so we kind of had to swallow the pill that the definition part has to look like an auto property. And that means that the implementation part can't also look like an auto property, because then we can't tell them apart.
Right. And if we didn't need the lock there in this example, I could implement just the get. That's and just have an arrow field, and that's enough.
Yes.
To make it work. So I don't have to type all of that.
Well, it's not a lot, right? So this is where it looks exactly like an auto property, and now I can't tell them apart. And also this needs to be private. But if I implement one of them a little bit, like just say I'll do the default implementation of it, which is to return field, then that's enough for it to do the rest of the auto property stuff with that. So it kind of helps me syntactically distinguish. That's a nice little extra bonus you get from the field.
Yeah. So I think that's a really useful way to say, you can go from this auto implemented property all the way up to, now I have a full algorithm behind it, and every step is smooth.
Yes.
And then there's one other thing related to this feature, and then I think we should move on and talk about more of the big things coming. Is one question there. Does this now mean that the backing field has a stable name? Can I count on reflection here, or not so much?
I think we are deliberately, so I'm not entirely sure here, but if I recall correctly, we decided to very much not give you a stable name. I'm not sure about that, but there's sort of like there's a way in which we have to be careful about what you rely on with reflection when it's for compiler generated things. I can't actually remember what we did with this one. Do you remember, Bill? My
recollection is also that we did not guarantee the name, but I would have to look at the notes.
Yeah. It's like the problem with guaranteeing names for these things is that then you start taking dependencies on that guarantee, and then that hems us in from an implementation point of view, and it kind of breaks the abstraction. So there's a trade-off there. I can't remember what we ended up with. We'd have to kind of go on.
Okay, so Per did get back, and you probably have a better answer here than I do, but it's probably worth a couple minutes, and then let's really talk about the big 14 things. So his question, remember, he was talking about using auto or using the overload resolution priority. So for instance, he would have something like this where I've got an unconstrained generic type parameter and a constrained type parameter, and now can I get it to bind to the more constrained one?
Well, yes and no. If you could declare both methods side by side, then you could definitely use auto, or you could use overload resolution priority to preference one. The problem is that you can't overload generic methods just on constraints. right? They can't look the same except for constraints. That's just a limitation of the runtime. Constraints are not a thing you can overload on. So you'd have to trick it somehow to be not quite an overload from the compiler and runtime's perspective. Like, these tricks like adding a default parameter or something like that, so that it becomes technically a different overload that still applies.
Then it would actually.
Then when you do that, then that overload might be deprioritized because of the overload, or because of the omitted argument by the default algorithm. And I think, so I'm not going to go do the experiment live here, but I think at that point, then the overload resolution attribute would help you out, because it does the priority applies fairly early in the sorting process. It's not just when you have two things that are equal and are competing. Like, it says, well, here are some candidates. If some have higher priority, throw out all the rest out. So if you can get to where you have two applicable candidates, then you can slap that on and get the last mile. So I think it will help you. Yes.
Okay. And then let's look at C# 14 and such. So we had one early comment here, which I think there's enough useful stuff in 13, but it's definitely true that we've been working on some big things. So this seems to be the one that has been mentioned a couple times. So probably ought to at least mention that one, and then we can. There's a couple others that I know we should talk about.
Yeah. Well, okay. Yeah. Let's start with, since the discriminated unions are mentioned here in a question, let's start there. So a lot of people have been asking for discriminated unions for a long time in C#. And we've been, unions, not everyone says discriminated unions. We've been trying to find out, well, what is it about unions that make people want them? So discriminated unions, for those people that aren't as familiar, are kind of like a bread and butter feature in modern functional programming languages. And they're sort of the corresponding feature to inheritance, to object hierarchy, to class hierarchies, which is what makes it hard, because we don't want to add a feature that's almost like one we already have, and then people will have two ways of doing everything. That kind of has to be like a way that it improves something. And there are a couple of things that people, when we ask, like, what are the things that make you want unions? So I apologize for not having, in fact, we may not want to look at the code anymore. I don't know. We can bring it up again if necessary. But one of the things that people ask for is just brevity. Is that instead of having to define a whole class hierarchy, like a base class and 7 derived classes, each with overrides of things and so on, well, it tends to be that discriminated unions are a much terse notification of the same. Like, for instance, you have like the union itself is like a type declaration, and then you have very brief things inside to say what the different concrete like versions of that are. And the different cases, as one might say. And the other thing is exhaustiveness, where typically with unions, you know exactly what different options are there. Like, there are these 7 kinds of things and no others. Whereas class hierarchies are open-ended, and sometimes another assembly will add more derived classes and so on. You never know if you've looked for all of them. And with pattern matching now in the language, it would be really nice to have like language help in saying, I know I covered all the cases. Don't make me put in a default case, because both you and I know it's never going to be needed.
Right. And the same thing with enums, where, because right now pattern matching treats that as the underlying integral type. I always need that underscore, something's bad here, which makes it hard to find all the places when I add another, another value in the enum. And it's like, I want to find every place I used it.
Right.
So I don't get that help. So yeah, we're definitely. Go ahead.
Yeah. So we went from, we looked a lot. We took a deep look at unions about 2 years ago. We took the whole summer to change the language design team, or the Northern Hemisphere summer, to change the language design team into a study group. And we looked in depth at a lot of more far out things. And one of them was unions. And since then, we've had periodically, and for the last year, consistently, we've had a group of people working on making progress in unions, and we made it quite far. And there's a pretty decent proposal, or kind of like outline vision document, if you will, that's up on GitHub right now. So it is something that we are now making design progress on. We're getting a lot closer to answer the question of, if we do discriminated unions in C#, what should they look like? Mm-hmm. It doesn't mean that we've solved all the problems, and it doesn't mean that we've concluded that this is indeed worth doing, but we're a lot closer. But a lot closer still means that even if it happens, which I think it will eventually, I'm very optimistic about that. Right. It will not be in C# 14 for sure. And it's very likely it won't make 15 either. Like, this is one of those things that we go spend time on, that, and as a result, we have fewer features in C# 13, and people are complaining about that. Like, we need to do those long-term investments as well. Yeah. And this is one of the ones that, from a design perspective, we've spent quite a lot of effort on this past cycle.
Now and the other one I really want to talk in, I really like the comments on discriminated unions. I'm going to grab some of these, and we should both pass them on to the working group for unions. There's some good comments here on it. That has been one of those areas that we've been investing in that wasn't quite ready, that I think it's noticeably closer now, is extension everything, which I think is the other really good one to talk about.
It's an example of the same kind of process, but where we're a little further along, including having stubbed our toes more times, where there was, so there's a problem that we have known about ever since we added extension methods to C# in C# 3. I think it was released in 2008. So extension methods have been around for a long time, and we fully intended, we did them in kind of like a syntactically hacky way, right? The static methods with an extra like little thing on a parameter, and magic happens. We had lots to do in C# 3, and we're like, let's not make a big deal of this. Let's not invent new syntax. Let's just, go. But immediately, because extension methods were much more popular than we thought they would be. Before we released them, there's a lot of anxiety. Are they going to hijack my classes? Are they going to be like this security hole? And once people got over that, I think even we were surprised at how useful an abstraction it is to be able to declare something somewhere else that puts extra members on a type, on an existing type. It's just such a great way for kind of like doing context specific stuff, and for discoverability of the things that work on that type that you built, and so on. And so it was a big success, but then also at the same time, people were like, so where are my extension properties? Where are my extension static methods? Where are my extension interfaces? Some people would also say, like, I want to not just add new members, I want to implement interfaces with them. And we're like, okay, let's think about this. And we actually, in C# 4, we did several attempts to say, okay, we took a step down this syntactic path, and let's see what it takes to kind of continue down that path for the other member kinds. And that just turned into a hot mess. We had multiple different proposals. We prototyped them, and everything just looked like a dog's breakfast. It was really, really bad, because it turns out that trick with this parameter only really works for methods. If you try to make it work for everything else, you're adding syntactic elements of the wazoo, and it's just like, and what about properties? They have two things. Is it a static method for the getter and a static method for the setter? And it just killed us. We pulled the whole thing from C#4, and essentially the whole area had been poisoned for a long time because we just thought we were in a dead end. And the thing that kind of really got us, then we had a big vision thing, right? That was about, there's this other thing, that there are type classes in functional languages like Haskell, and there are type providers in F# that let you kind of pretend that there are some things have types that they don't really, and so on. And there was this big thing, this big unified thing that was roles and extensions that came out of that. That was like another vision document, essentially saying, hey, we could solve all of these problems with this like grand unified feature. And we then set out to do the first part of that grand unified feature, and more things turned out to be impossible or hard. And we are now down to where we thought we could ship something in C#13, and we even showed it at the Build conference, and it just realized that the things we had left to do were much bigger than we thought they were.
Mm-hmm.
So we are now down to where the stuff we're looking at right now is extension everything, in the sense that it is the ability to add all kinds of extension members. And we're looking at syntactic alternatives, but what they have in, like this week, we spent the whole design week discussing these syntactic alternatives. What they all have in common is that the syntax for declaring a member, an extension member, is not a static method. It is a thing that looks like that kind of the kind of member declaration that you are trying to make. Like if it's an extension property, it looks like a property declaration. If it's an extension operator, it looks like an operator declaration, and so on. But we're still hashing out some details, to put it mildly.
Yeah, and there's one question on this feature. Based on the current designs, would you be able to extend a class I don't own, and then extend it so that it implements an interface, and then I can pass that thing to a method that requires that interface or that extension?
Yeah, unfortunately, extension interfaces was one of those things that fell by the wayside. Yeah. We couldn't see a way to do it with the current runtime, and we couldn't even see a good way of doing it with an envision change to the runtime. We've been down many paths on that and worked with the runtime team on it, and we haven't found the sort of key insight that would let us do it. It's also the case that as soon as I'm hopeful that eventually we will solve that, and we will do that, and we'll change the runtime. But the thing to keep in mind is that when we do a feature in the runtime, and we do features in the runtime from time to time, then that's a language feature that doesn't work down level, right? So that's something to keep in mind as well, that people will only get that feature when they're actually on the runtime and the C# language version that this came in with. That's generally fine, but it's also something to keep in mind.
So yeah, there's one or two more based on extension methods, and then we're getting to near the end, so then we should finish up with anything else that you want to add. Can we add state in an extension?
Nope. The short answer is no, and the reason is that we would sort of have to do a bigger magic trick in that sense. Like with extension function members, you are pretending, yes, that the object has this extra member, but we can sort of just, every time you call the member, we can start pretending at that time, right? We can say, okay, you get to call it, and then when you're done, you can forget about that connection. But if there was state, then we would need to remember it between every time you access it. And that means we would need to store it somewhere. It can't be on the object itself, because that object actually isn't affected by extension members at all. We don't want it to. that we get into all kinds of trouble. And so that means we need to find somewhere else to store additional state for a given object at the first point where somebody has asked for it. And you can imagine how gnarly that gets. Now, we do have conditional weak tables and so on that we could use for that, but we think that's too much magic with too much performance impact to do transparently. Because it would look like a field, but especially from a performance standpoint, including also blocking behavior and so on, if we wanted to harden it against multi-threading, that's not something we should just do on your behalf. But it's an option for you if you have a convenient place to stash extra state. You do your extension, you do it as an extension property, and you do the magic yourself. Like, you put it where you want to put it, or if you have a whole scheme for it, maybe you write a little source generator that will generate that code for you using a partial property that we now give you.
Okay. And now with about a little more than 5-6 minutes left, is there anything else you want to cover in terms of where we're going with C#? What other ideas are we investigating that you want to bring out at this time?
I can certainly rattle off a few. I mean, we mentioned the story arc of kind of collection creation before. Started with collection expressions, and now we have params collections. There are a few more things that we would like to do with that story that we haven't done yet. One of them is we would like to have dictionary expressions. So there are definitely fewer dictionaries than there are other kinds of collections in the world, but there are still a lot of things that are dictionaries. And it'd be convenient if we can expand the collection expression syntax to be cognizant of key value pairs and to work consistently across dictionary types when you have like a key value style expression with the same level of consistency of experience that we have for collection expressions today. So that's something that we have a proposal and a lot of details already nailed down. We just haven't gone the last mile. I'm actually hopeful we might get to this in C# 14, but I'm making no promises. The other thing is, you know how Lambda expressions, for like anyone here who has been around for more than a couple of years, Lambda expressions didn't used to have a type of their own. Many of them still do, but still don't. But it used to be that the only way a Lambda expression could get a type was to be assigned to a type, a delegate type or an expression tree type, and then we would generate an object for it. And then eventually we said, well, this is annoying. I often why do I have to say this whole delegate type when it's perfectly obvious that this is an action of int, string or whatever, and so we let the compiler do the perfectly obvious, and now many Lambda expressions do have what we sometimes call a natural type. The type it has if it's not being assigned explicitly to a type. Like if you just say var x equals this thing, that's a type you'll get. Instead of an error, you get a type. Great. Same thing for collection expressions. They currently don't have a natural type. Like if you just put a square bracket, some elements, maybe some spread elements, suck other collections in and so on, end square bracket, that does not have a type. And for some of them, it's probably fair that it doesn't have a type. Maybe none of its elements have types, maybe it's null, null, or null, default, or something like that. And we would have, no chance of figuring out a good type for it we could think of something. We say they're all object or something like that, but that will probably be worse than nothing, because then it won't be what you wanted later. So it'll be a situation again where not all of them can have natural types, just as for lambdas. Some of them could. And then the question is, what should that type be? What kind of collection? If we can figure out the element type, the next question is, what kind of collection should we create by default? if you say var(x) equals square brackets blah blah blah, should that be an array? Should it be a read-only span? Should it be a list? Should we go for maximum? If we want to go for maximum performance, it should probably be a read-only span or something. But if we want to go for maximum utility, it should probably be a list of t that you can add to and do all kinds of other things with. And that's like a philosophical question there about what we go for. But once we solve that, it'd be really nice to solve, because then you can have things like for each var(x) in and just some square brackets, right? And that, that'd be a really nice syntax for iterating over just a bunch of elements you already have in your hand. So we really want to solve it, or we may even solve the for each one separately, just so we can get that in people's hands. But the greater question is that's probably the last one I'll mention, given what time we're at.
Two quick questions that I think have quick answers.
Okay, let's try.
So I'll start with this one. If there's anything going on with interceptors, or if that's kind of getting more feedback and waiting for a bit.
I think it's staying experimental, but I'm not quite sure, because we have we've tinkered with it quite a bit, and it's getting better and better. But we're taking our sweet time. Most people who make use of it are doing advanced stuff with source generators, and so we kind of say those are also people who can live with things being in preview and changing more over time and so on. We're like, you're a super user, deal with it.
And then one other one, if you don't have the answer, I can speak to this a little bit. What about an expression for a statement list?
Yeah, that's another thing we've looked at, exactly. Like sometimes you're in expression land, right? You're in the middle of an expression, have a beautiful new switch expression or something, and there's a branch in there where you just can only be an expression, but I just wanted to, maybe I just even want to log something, or I just want to declare an extra variable and do, and all of a sudden I have to go all the way out to the nearest statement space in order to do that. And sometimes there isn't even one. Right? What if you could take a statement block and have it be an expression? That's another thing that we're investigating currently, because there are many answers to questions like, how do you get a value out of a statement block? And all the obvious answers have problems. So that's an open question, but a active investigation. That's a really good one. Thank you.
And I think that we've pretty much gotten most of that. And with that, I want to say a big thanks to Mads. I certainly enjoy all my time working with C# LDM. It's some of my favorite hours of the week. And thanks to everyone coming today to talk about all the things that we have in C# and the direction we're going, and keep using it in the future and keep giving us more feedback.
Please do. Thanks, everyone, also for great questions.
Yeah, thank you. Great participation. And with that, have a great rest of your day, and leave us comments.